Hello everyone, my name is Can Coşkun. Today I will present my Physics 101 lab project about investigation of the dependence of an inclined plane pendulum's period on the angle of inclination. The main objective of this experiment was to observe how the period of a pendulum changes when the plane's angle is varied. Theoretically, on a frictionless inclined plane, the effective gravitational acceleration is reduced to g times sin theta. This leads to a linear relationship where the square of the period, t square, is proportional to inverse sin of the angle. For the experimental setup, I used an integrated airtable system to minimize friction. There's an air and spark pedals, an air compressor, an air table, pipes goes throughout the puck, and a spark paper. The pendulum puck was attached to a pivot with a string. The length of the string was kept constant at 0.38 meters throughout the experiment. I used support blocks to set 5 different inclination angles with non-sin theta values, ranging from 0 to 0.16. Firstly, I didn't use any support blocks in order for equalize the sin theta to 0. Then used the block sin theta equals to 0.10, 0.12, 0.14, and lastly 0.16. In this video, I used the block that sin theta value is equals to 0.10 and that block is equals to 0.12. In this video, the block sin theta value is 0.14 and in this video, the block's sin theta value is 0.16. Here are the measured periods and processed data. Plotting the required relationship t square versus 1 over sin theta, we observed a strong linear correlation, which is excellent. The data fits the linear model y equals to 1.57x. The slope m of our best fit line was determined to 1.57 second square. Using the slope and our known length, we calculate the experimental value of g. Comparing the result to accepted value of 9.81 meters second square, we calculated the very low percent error of 2.55%. This high level of accuracy confirms the theoretical model. The period is inversely proportional to square root of the sine of the angle. While the error is low, the experimental g value was consistently lower than expected. This deviation points to a few systematic errors. First, the air hose connecting the puck introduced the air hose drag, which slightly distributes the simple harmonic motion. Second, residual friction from air resistance and surface impressions oppose the motion. Since g is inversely proportional to t square, any force that artificially increases the period t, like drag or friction, resulted in a lower calculated g. In conclusion, the experiment successfully confirmed the pendulum's period on the inclination angle with high accuracy. Thank you.